Welcome to the Select Committee on Energy Independence and Global Warming and a briefing which we are going to have on the global warming impacts on the Arctic region. We have three very distinguished expert witnesses who will be here today in order to give us the expert testimony which we need in order to understand these phenomena as they are unfolding across the planet. Last week, an ice sheet covering 100 square miles broke off of Greenland. This giant ice island is more than 4 times the size of Manhattan. It is the largest piece of Arctic ice to break free in nearly half a century. This event follows the warmest 6 months on record, which is on the heels of the warmest decade on record. Scientists, skeptical by both nature and training, always urge a dose of caution when looking at any one event as evidence of climate change. This level of professional skepticism is what makes the overwhelming scientific consensus that climate change is real and caused by man all the more powerful. Scientists have warned us that climate change will result in increased melting of glaciers and polar ice, more frequent and intense heat waves and wildfires, and increased drought and flooding. With that prognosis in mind, let us review some of what has happened during this hottest 6 months on record. Russia is suffering both the worst heat wave and the worst drought since record-keeping began more than 130 years ago. This brutal combination is now killing 700 people a day in Moscow alone. More than 600 wildfires have scorched more than 465,000 acres and destroyed thousands of homes. 25 million acres of grain production have failed, causing Prime Minister Putin to ban all exports of grain. The extreme floods slamming much of Asia may prove to be the biggest humanitarian disaster in memory. In Pakistan alone, 13 million people are affected. And Americans up and down the eastern seaboard have endured day after day of record-breaking temperatures. Megastorms and floods have rocked many regions of the country, including my home state of Massachusetts, where we had 2 50-year storms in the course of 2 weeks this past March. Take a step back from those individual pieces, and we see a mosaic that could not be clearer. Our world is becoming less hospitable with every passing year. The melting of the Greenland Ice Sheet is but one harbinger of the many changes to come. I am delighted to have a panel of experts here before us today who can help us understand why a massive piece of ice broke free from Greenland last week and how it fits in with the deeper and more disturbing phenomenon of Arctic warming. So let us begin with our expert witnesses. And our first witness is Dr. Robert Ben Shadler. He serves as a senior scientist at the University of Maryland, Baltimore, and he is also an emeritus scientist at NASA's Hydrospheric and Biospheric Sciences Laboratory. His research includes 15 Antarctic field seasons and 30 years of work with remote sensing data of ice sheets with NASA. We welcome you, Dr. Ben Shadler. Whenever you feel comfortable, please begin.
Thank you very much, Mr. Chairman. It is quite an honor and a privilege to have received the invitation to come here and testify today, but I also feel it's an obligation of Earth scientists to give.
Could you turn on your microphone, please? Okay, could you turn on your microphone, sir?
Yeah, I had pushed it.
Yeah.
The light's on.
This is a larger.
Can you hear me now?
Who did this one? Do you know?
The light is on. Should I use another microphone?
So that one is a larger print.
Even closer.
Yeah.
Okay.
Great. Thank you.
Yep. As I was saying, I feel it's also an obligation for Earth scientists such as myself to come here and take the opportunity to inform you of what is going on. My particular expertise is the cryosphere and ice dynamics. And so I'll primarily give some context for this most recent observation and leave it to my colleague Andreas to give more of the details. So next slide, please. I'm sure Andreas will speak more about the details of this particular calving event. So I'll just move on to the next slide. My short answer to what the impact of this event is indicated here. That in my view, one of the major impacts will be that we expect the Peter Melling Glacier that fed this ice shelf to speed up, something like a factor of 2, because glaciers always speed up when ice shelves break off in front of them. And so that's an expected consequence. And of course, that's going to increase the drainage of the Greenland ice sheet and contribute to rising sea level. Another impact, I think, is that the observation is one of a consequence of warming, but we're talking about the northern reaches of the Greenland ice sheet, and that shouldn't be lost. The location of this glacier is on the northern extremity of the Greenland ice sheet, so we're seeing impacts on the Greenland ice sheet throughout its full extent, and that's, I think, worthy of note. But I think the more important question in the context that I want to speak to is indicated on the next slide. What are ice sheets going to do? That's really the big question that my community is working on very, very hard. Next question. Next slide, please. Just a comment here that glaciers and ice sheets grow because it snows, and that's continuing. That's actually increasing in some places. But they also melt and calve. They've always been doing this. They always will be doing this. But the key issue is which of those processes is the more dominant, which is the bigger term. We call it mass balance. Next slide. And satellites give us the answer. Satellite data through a variety of satellites, a variety of methodologies, tell us that around the margins of both the Greenland and Antarctic ice sheet, a lot of thinning is going on. That thinning is driven primarily by the acceleration of outlet glaciers, such as the Peter Melling Glacier. This is happening in both ice sheets at large rates, and in fact, it is the dominant term affecting what we call the mass balance of ice sheets. They're losing mass, they're raising sea level. Next slide, please. An even bigger picture comes from paleoclimate data. So what is shown in this particular slide is a comparison of how sea level has gone up and down, up and down, up and down over the last 400,000 years. And also how temperature has warmed and cooled, warmed and cooled, warmed and cooled over the last 400,000 years. And the point of this illustration is that those two very independent parameters behave exactly the same way. Temperature does drive sea level through the process of growing and shrinking ice sheets. So this is something we know. This is something I would classify as a known in science, that as the Earth is getting warmer, ice sheets are going to shrink and sea level will go up. There's no doubt about that. Next slide. The key questions here for experts such as myself are these. Why and the how should really be how much is sea level going to go up and when is that going to happen? And that's where the research is going on right now. Next slide. The one-word answer is that water is the primary agent driving these major changes. And I illustrate here 3 particular processes, whether it's disintegrating ice shelves where surface meltwater is driving crevasses deeper into the ice shelf, breaking them up, or whether it's the Self-lubrication, surface meltwater getting underneath the ice sheets, lubricating them, allowing them to go faster, or whether it's warmer water from the oceans circulating underneath the ice shelves, thinning them, and again, allowing the glaciers to go faster. These are the processes that are being studied right now very intensely by the research community, and these are the processes that are deemed responsible for ice sheet shrinkage and sea level rise. Next slide. The best answers we have, this is sort of our view of sea level rise history. In the past, these data are taken from the IPCC report. My colleague Richard Alley was a Nobel Prize winning contributor to that report. And an important aspect in the projection of sea level, which is the blue wedge on this slide, is that it has a certain range, but it does not include the ice sheet dynamics. And a very important text in that report makes that very, very clear. So the next slide, if you consider, on the next slide, please, if you begin to include ice sheet dynamics, as well as we can do right now, we have ranges that begin to bracket 1 meter and beyond as likely levels of sea level increase by the end of this century. And that's really a statement of where the research is right now. These are our best estimates of what sea level is going to do. This is why monitoring events such as the calving event on the Peter Melling Glacier are so important. Final slide. Some of the impacts here. Why we know it's a global issue. Oceans surround every continent on the planet. It's going to affect millions and hundreds of millions of people. This is just some data for your consideration. How much area will be lost? How many people are living now within the 1 meter of sea level, and what the economic value of that property is. Final slide. And then my final point here is that we need to keep talking. The research community needs to continue to interact with the policymakers and the planners. I just list a few specific instances of that going on just this year, and you'll note there that there's a lot of hard work being done by the research community to get the right answers on this. When is sea level going to rise, by how much, for the sake of policy making and planning. And a very important milestone out on our horizon is the next report from the Intergovernmental Panel on Climate Change, the 5th assessment report that will be out in 2013. Thank you, Mr. Chairman.
Great. Thank you so much. Our next witness joining us on the phone is Dr. Richard Alley. Dr. Alley is a professor of geosciences and earth and environmental systems at Penn State University. He served as a lead author for the 4th assessment report of the Intergovernmental Panel on Climate Change for Chapter 4, Observations, Changes in Snow, Ice, and Frozen Ground. He is a member of the National Academy of Sciences. Thank you, Dr. Alley, for joining us.
Mr. Chairman, thank you so much. May I ask first if my voice is coming through clearly?
Yes, it is.
Very good. Thank you. My apologies that I'm not with you, but I'd like to thank you for your forward-looking and saving the impact of having me come down there. So it's a pleasure to join you. It's a pleasure to follow Dr. Ben Shadler. I hope I have a slide up that just gives my association there. And if you'd simply go to the next slide. I had the very good fortune to serve the U.S. government preparing one of the Climate Change Science Program reports, the CCSP report, in which we looked at the history of the Arctic. This was published by the U.S. government in 2009. We have now published all of the main pieces of that in the refereed scientific literature as well. I would point out that because of the late-breaking nature of the news here, I have not been able to contact the other authors of this report, so I'm simply speaking as me, but I will try very hard to represent what they've said. If you'll go to the next slide, please. A few key results that came out of that U.S. government report and that have been published in the scientific literature. First of all, when the world warms, the Arctic tends to warm more. The Arctic is where Greenland sits, so this is important. We have seen that there's recent loss of sea ice in the Arctic. This is a little bit surprising because the big long-term features of the Earth's climate have been pushing towards having more sea ice in the Arctic, but now we're seeing this very rapid loss up there, and sea ice loss tends to amplify the warming. Now, what we're seeing is that in the past, nature has certainly changed the climate. It has had large, rapid, interesting changes. What's going on in the Arctic now is sort of as big and as fast as the biggest and fastest things that nature has done. What we expect under business as usual, if we humans keep doing what we're doing, is that the changes will become anomalous in size and duration compared to what nature has done. That we're actually going to end up pushing nature harder than it's had done on itself. And this is all important because these changes that we see happening in the Arctic that are going to becoming anomalous, that lead to warming, have a big impact on the Greenland Ice Sheet. And when we look at the history of the Greenland Ice Sheet, what we find is that a few degrees of warming has been sufficient to remove the ice sheet. And so if you'll click to the next slide, please. I apologize, it's a slightly messy-looking graph. What's shown here on the left is how much sea level rise has come from Greenland's ice. And shown on the bottom is how much temperature rise gave us that in the history of the ice sheet. And there's various numbers which indicate times in the past. The key one to look at is in the upper right there, which indicates a sea level rise from Greenland of about 7 meters. A little more water than the deepest water that was in New Orleans after Katrina, for a warming of a few degrees, 4 degrees or so, with an uncertainty that's a couple of 3 degrees. And so what we find from looking at the history is that when the world warms, the Arctic warms more, and when the Arctic warms, Greenland melts. And it's sort of that simple. When the world warms, the Arctic warms more. When the Arctic warms, Greenland melts. And so if you'll click to the next slide, we do know that when it gets warmer, we melt ice and raise sea level. There is generally more snowfall with a warmer world in the very cold places, but this loses. The warming melts ice and raises sea level is what the history indicates, as Bob showed you as well. So far, we don't believe that you can lose an ice sheet in mere decades, that it would be at least centuries to actually melt a whole ice sheet. But we do find scientifically very clearly it is easier to get rid of an ice sheet than it is to grow it back. In the popular language, this is sometimes called a tipping point. If you push it too far, it goes away, and then it's hard to get back again. And it's fairly clear that there are tipping points that are at least as worrisome in the Antarctic as the ones in the north. Well, we don't believe it's possible to lose an ice sheet within decades. We might cross a tipping point within decades, which would then commit us to losing an ice sheet over centuries unless there were some really huge change in the climate we really got control of it in a hurry. We can't give you really solid numbers at this point. That last bullet there, many decades ago, the U.S. government said we need to understand climate. We're going to have our government labs, our funding agencies are going to build models that will help us understand climate. And a few decades ago, a decision was made that an ice sheet is a large white mountain that doesn't do anything. And so now the labs are trying to catch up, but it's very clear that our understanding of ice sheets lags behind our understanding of many other pieces of the climate system because we started very much later to get serious about this. So if you'll just click to my last slide then, it's a pretty picture I took in Greenland, but what we do find, warming brings changes that shrink ice and raise sea level. We're learning a lot in a hurry, but the uncertainties are big, and it's going to be a little while before we'll have really confident answers for you. And I thank you very much for the opportunity to address you.
Thank you, Dr. Alley, very much. And our next witness is Dr. Andreas Min Chow. Dr. Min Chow is Associate Professor of Physical Ocean Science and Engineering at the University of Delaware. He has conducted National Science Foundation supported research on the Petermann Glacier in Greenland, which we are discussing here today. We welcome you, Dr. Min Chow.
Thank you so much for the
If you could move the microphone in close to you and turn it on.
Okay. Thank you so much, Mr. Chairman, for the opportunity to testify before the Select Committee.
Could you move the microphone in just a little bit closer, please?
Like this? Okay. Thank you so much for the opportunity to testify before the Select Committee. I will talk only about Petermann Glacier, where current events offer exciting new ways to explore a unique outlet glacier with great potential to uncover unexplored physics of changing ice-ocean atmosphere interactions that may be missing from current generation IPCC models, numerical models. In 2003, a small group of scientists from Canada, England, and the US worked off northern Greenland aboard icebreakers for 3 to 4 weeks at a time in 2003, 6, 7, and 9. Last week, Thursday morning, Dr. Melling received an email from Trudy Wohleben on a breakup of Petermann Glacier. Everyone in our research group, that includes all these different countries, knew about it within seconds. The next 8 hours, a flurry of emails, data, ideas, as well as calculations on ice, tides, winds, satellite data, went back and forth across 9 time zones. We forgot the rest of the world until we were called back by one of our spouses. This is how science works. Figure 1 that is shown there is the outcome, one of the outcomes of those 8 hours. Dark colors are water, yellow is glacial ice, red are ice sheets at higher altitudes, blues are either landforms or, if on water, sea ice. From images like this one, ship-based expeditions to Greenland between 2003 and 2009 that we have been part of, and a review of the literature, and I will not name all those names on it, there's 3 that I can give you later, and we find that an ice island was born August 5th, 2010, that measures about 240 square kilometers in area, about 4 times the size of Manhattan. The ice island has a volume of 18 square kilometers and a mass of about 16 gigatons. This corresponds to a freshwater equivalent of about 2 years the average rate of the Delaware River, or about 120 days of the total US public tap water consumption. This is from a USGS, US government website. Smaller but similar sized ice islands formed between 1958 and 1961, when the glacier lost the equivalent of about 2.8 Manhattans. And I can give you the number, but I keep with the Manhattan units for now. While in 1991, Petermann Glacier lost about 1.7 Manhattans. In summary then, Petermann Glacier has had 3 large calving events which took place near 1960, 1991, and 2010. Last week's event was the largest, but since these large events occur only about every 25 years on average, the annualized rate of discharge is only about 0.6 gigatons per year for this event that we just witnessed. This number is identical to the number for the 1953 to 1978 period, and this is in a paper, peer-reviewed paper by Higgins, 1991. This is one of the reasons, namely that those numbers for the 1953, 78, and 1991 to now, that these numbers are identical. This is one of the reasons that scientists expected a large breakup that did indeed happen. Implicit in these expectations that we all had is the assumption of a stable flow, a steady state at decadal timescales, and the observed constant calving rate. Now, for implications of significance, the annual calving rate is only 5% of the 12 gigatons per year that the Greenland Ice Sheet gives to Petermann Fjord at the grounding line, where the glacier is in contact with the bedrock. Rigneau and Stefan in 2008 find, quote, most of the difference in flux between the grounding line and the ice front is caused by the removal of ice from the bottom by warm ocean waters, end quote. More detailed calculations by the same authors reveal that 80% of Petermann Glacier is melted by ocean water from below the ice. The ice is floating. Surface melting accounts for the remaining 15% of the mass lost. The recent discovery 2 years ago, of complex under ice topography, and this is my next slide, with valleys and ridges 200 meters high in scale over a few kilometers, furthermore emphasizes that the floating glacier, Petermann Glacier, is not a flat plate. So since this goes up and down, there's a much larger surface area in contact under the ice, in contact with the water. Nobody knows how these under ice channels are formed or what causes them, but there are a number of speculations and most exciting boundary layer physics to explore to better predict melt rates and mass balances for Petermann Fjord. In summary, we really do not know how the dominant ice-ocean boundary layer physics work in response to climate change scenarios. We are rapidly improving our knowledge of surface ice velocities, air temperatures, and ice thickness, but even more potential exists to improve less visible but no less important ice-ocean interactions for IPCC numerical modeling. That, to me, is the only way to quantify the contributions that global warming makes to the climate system and perhaps even extreme events. Global warming to me is very real, as I'm an avid gardener. My Native American azaleas start blooming a few days earlier every day, despite all the variability in 10 years in temperatures and moisture. Global warming may be one contributing factor, perhaps minor, perhaps not. But the adjacent hybrid azalea, a different plant, but still an azalea, always blooms at the same time. Why would one plant be affected by global warming and the other not? I can't answer that question. The situation with Petermann Glacier and those to southeastern Greenland is perhaps similar. If different physics dominate different glaciers, I would expect a different response to a uniform forcing by global warming. I believe that only ensemble averages of numerical models can decide what is and what is not global warming over scales much larger than one outlet glacier. This is what the IPCC projections have been doing very successfully. Data on ice-ocean interactions are needed now to develop the next generation numerical models, as well as to later test the projections that perhaps will become predictions. This, in my opinion, is the only way to make attributions of observed changes to global warming. Thank you so much.
Thank you, Dr. Min Chow, very much. We very much appreciate the testimony of our three experts. The chair will now recognize himself and ask this question of each of you. It seems to me that the breaking off of the giant iceberg is consistent with warming, but it is not the total story here. It's the sexy headline, but not the real story. The real story is much scarier. The question is, what overall is happening to the ice masses of Greenland and Antarctica? So give us a bottom line. Is the Greenland ice mass increasing or decreasing in mass on a net basis? Dr. Ben Shadler.
Well, the answer to the question is that both the Greenland ice sheet and the Antarctic ice sheet are losing mass on an increasing basis. And one of the figures in one of the slides I chose specifically because it makes that point most clearly. It's from a satellite called GRACE, whose function is to monitor mass around the Earth. So as it flies over an ice sheet, basically what it does is weigh that ice sheet. And so it started in 2003, so we have 7 years of record, and we can see winter accumulation as the ice sheet grows, increases in mass, and summer loss of mass. And so year after year, we see that seasonal fluctuation. But superimposed on all that is not only a decreasing trend in mass, but a decreasing trend that is losing mass faster and faster and faster. So those are hard data, and there's just no disputing that is going on. So that's I think the best view of the big picture.
Okay, thank you. Dr. Alley.
Yes, and to build on what Dr. Ben Shadler said, we have tried very hard to understand the reasons why we see the ice mass happening. We do see loss. Greenland is getting more snow in the middle, so it's thickening a little in the middle, but the extra loss on the edges beats that. So Greenland is losing mass at an accelerating rate, and that appears to be because it is melting more on top from warmer air, and it is dumping more icebergs into the ocean from warmer water as well as from the warmer air. In Antarctica, it appears that warmer water has been very important in causing the changes. So our understanding is that the warmth is what causes it. We could have a long discussion of exactly why the warmth has happened in Antarctica, but the warmth in Greenland, at least, is fairly clearly because the climate around it is getting warmer. So we're seeing ice loss from a warming world.
And Dr. Alley, you know, in your synopsis, you say snowfall generally increases with warming, but not enough to stabilize the ice sheet. So that's a paradox here, that you actually see more snow, which is what you're reporting in the internal part of Greenland, while the overall story is that the totality of the ice is in fact shrinking. Is that correct?
That's correct.
Okay, great. Dr. Min Chow.
I'm speaking only to Petermann Fjord.
Could you please move?
Okay.
Good.
I can speak only to Petermann Fjord, specifically, or Petermann Glacier, where even an impressively large chunk of ice being discharged into the ocean, to me, does not conclusively prove that that this specific event is global warming. I'm not saying it is not global warming, or that global warming does not play a role.
I'm just asking the question of whether or not, in fact, the overall ice mass is increasing or decreasing.
And with overall, you mean integrated over all of Greenland?
Yes, right, on a net basis.
I would agree on that statement.
You would agree on that?
I would agree with Dr. Alley and Dr. Ben Shadler.
Great, thank you. I appreciate that. Let me turn and recognize the gentleman from Washington State, Mr.
This is perhaps a broader question. The week of August 5, that was when this event took place, is that right? When was the breakup?
The breakup happened last Thursday, kind of.
August 5. So that week, on August 5, we had a breakup. We had a report a month or so before that about incredible shrinking ice in the Arctic, something like a 40% reduction of Arctic ice mass. We had mass flooding in Pakistan. That week we had peat bogs on fire in Moscow, where now the people where they used to film Dr. Zhivago are wearing masks because of the peat bogs are on fire. We've got, in my little place, I live in Washington State, we can't grow baby oysters because the oceans are so acidic that the baby oyster larvae can't handle the acidity. All these things are happening around the world that one would think would be pretty disturbing, leading to the conclusion that there's some significant bad events out there in the future for us. Here's a question. How bad does this have to get till fellows like you will basically come to Washington, D.C. and shake members of the U.S. Senate by the collars until they understand how bad this situation is? How bad would it have to get till you felt personally compelled to sort of blow a bullhorn in somebody's ears until they wake up and smell the roses about these problems? That's a personal question to you.
To me personally? Okay. I think an event like this, the breakup of an admittedly large piece of ice from Petermann Fjord, that has happened at least twice before the last 50 years. It's not unprecedented. It's in the overall context of Petermann Fjord or Petermann Glacier, it's a small effect. That would not get me to Washington, D.C. to go to my congressman or to kind of, as a citizen say, gee, something has to be done. That event.
So what would? I mean, as a person of science, and I'm not a person of science, but I have to tell you, sitting to see these changes going around across the globe, and this thing is just like a pinprick that we're talking about today in this one little glacier. I'm talking about changes going around the globe of multiple systems, of multiple dynamic systems, which seem to be all moving in one direction, which is in the wrong direction. And I guess the question is, and I ask this to you because there's no one else from the scientific community, what does it take to get the scientific community to sound the alarm individually?
I think the scientific community that I consider myself a part of is not doubting, is overwhelmingly convinced that we see a lot of variability, we see a lot of changes that that at times is dramatic.
Well, let me just ask. Let me ask.
The question is, I as a scientist, I like to stay with the data, and in areas of the Arctic where there is large changes happening, and there are areas where large changes is happening, and I agree with prior testimony that the slow disappearance of the sea ice cover in the Arctic Ocean, that is indeed a large story.
Does it disturb you that the Arctic oceans are 30% more acidic than they were in pre-industrial times? Does that disturb you?
It also disturbs me that the IPCC projections have actually been extremely well in anticipating that.
So here's the question.
We actually let me just finish because I think it's important that I'm on the record to have said that the changes in the Arctic Ocean, the observable changes in the Arctic Ocean, have been anticipated by the early IPCC reports. So there we actually have numerical models projecting forward in the future. Now we are forward in the future, and comparing those two, what we see is that if anything else, those IPCC reports have underestimated the impacts that increasing CO2 and increasing global temperatures has had. So in that sense, we should not really be all that surprised. I'm not denying global warming. I'm not denying any changes that happening. What I'm objecting to is that in an event like this, in this specific event, all flags go immediately up. Oh, let's explain this by global warming. I cannot support that because I do not know for this specific event if it's being caused by globally raising air temperatures or not. But at the same time, I cannot prove. I can neither say that it's not a contributing factor. But in this specific case, for this specific breakup, I'm not alarmed. I'm not worried.
I appreciate that, and I think you've made your point really clear. I just want to leave you with one observation. We know that there are hugely dangerous things going on in multiple environmental dynamics right now. You pointed one out, ocean acidification, which you do say you're concerned about. Multiple places of ice loss around the world, multiple increase of severe moisture rain events, flooding from Tennessee to Pakistan, from goodness knows where. And this is going to continue and be unabated unless we get a little more help from the scientific community when you do see the totality waking people up here in Washington, D.C. what's going on. We need your help. I'm just asking you for help. What you do know, I hope you'll share with members here so we can get the U.S. Senate off the dime. Thank you.
Thank you. Why don't we let Dr. Ben Shadler and Dr. Alley ask the same question answer the same question that Congressman Inslee asked.
Thank you very much, Chairman. Because I would tell the Congressman that I am disturbed by what I see happening in the science, in the data. I will agree with my colleague Andreas that individual events cannot be attributed to a climatic context, just like any particular drought or any particular flooding event or a calving event. However, I think the IPCC Fourth Assessment Report was very clear, coming from the broader science community making a very strong statement about not only the synthesis of the published results, but also the synthesis of the projections and the impacts on humans around the world and ecosystems around the world. I think that was a very strong statement. You weren't here to hear my testimony, but I said at the beginning that I feel it was my obligation to accept the invitation to come here and testify today, because I am so deeply disturbed by what I see happening in the polar regions, which is my particular expertise. And if there are, and I concluded my testimony saying that we had to continue an increased dialogue between the science community and not only policy makers, but also community planners. And there is more and more of that interaction going on, and we need more and more of that, because the science community does have information that is actionable and does need to be acted upon. And if it's shaking the collars of congressmen, if you'll stand beside me, I'll do it.
Well, I'll go. I mean, I'm very serious about this. You hear dialogues from members of the U.S. Congress totally foreign to the existing scientific information.
Yes, sir.
And we need scientists who will come out and very personally and very vocally and very dramatically demonstrate to elected officials what the science is. And I have to tell you, if there's an asteroid headed to the Earth, I think the scientific community would be a little more vocal. But we have a very slow motion, similar situation. And yet, I don't see 100 people in lab coats surrounding a member elected official and explaining science to them in vocal terms. I see people in other groups that, for instance, might be associated with a group that celebrates tea surrounding members being vocal. But I don't see the scientific community being vocal about this subject. So I'm encouraging you to be vocal, and I think that's an obligation based on the gift of intellect that you've been giving. We need you to get out there and speak out and not let these people march forward in blind ignorance on this subject. So I'm giving you license to be vocal. Thank you.
Each of our witnesses was willing to come here on 24 hours notice to participate, which perhaps distinguishes them in a significant way from many others in the scientific community. They are here part of the political process, and we thank you for that. Dr. Alley, would you please address that question?
I certainly would, and thank you very much for that. I think all of us, sir, are very well aware of taking your words to heart, and I thank you for those. We face a difficulty in that there are certainly perceptions that if people take statements that can be viewed as being policy prescriptive, that it weakens our ability to be honest brokers about the science. As a scientist and as a citizen, as a voter and as somebody who's using your money to try to tell you what we know, I grapple with this. I think all of us do. I would greatly welcome guidance on how we can do this better. And if you call, today I'm on the phone, but tomorrow I can be in the car and on the way down to visit, to work with you, to talk with you, to try to move forward. All of us see very clearly what is happening. I had the very good fortune to be speaking to one of the staff members on a related committee recently, and that staff member said, "What is the single strongest piece of evidence that holds up your global warming theory?" And my reply was, "What is the single thread that is strongest in a rope?" Our observations, Peterman Glacier does not prove global warming, but thermometers show warming. Thermometers far from cities show warming. Thermometers in the ground show warming. Thermometers in the ocean show warming. Thermometers on satellites show warming. Everywhere we look, the changes in living things, 90% of the significant changes are in the direction of warming. The ice really is changing. This is happening. We see it. It is an interwoven rope of evidence that shows very, very strongly that we humans are changing the world in a way that will impact us in major ways. And how best to communicate that message to people, that is good, solid science. It is woven together. There is no thread that you could cut out of that that will change that conclusion because it is so strongly based. How best to communicate that, sir? I believe you're better at communication than I am, and I would happily go to school for you.
Thank you, Dr. Alley, very much. First of all, let me just say that if I have learned anything in the dozens of hearings that I have chaired in both this committee and in the subcommittee on energy and environment, it is that we cannot attribute a single isolated weather-related event to global warming. And I stated that in the opening paragraph of my opening statement. So I know, Dr. Min Chow, you keep knocking this down, but I stated that as the bottom line of how I am viewing this issue. But we have a larger point here. Mr. Inslee has made it. Dr. Ben Shadler and Dr. Alley has made it. There is a pattern here. The increased frequency and intensity of many of these events is exactly the hallmark of global warming. It is exactly what the science tells us should happen during global warming. And the science is moving very quickly to reduce the uncertainty associated with the projection of what is likely to happen in a warming world. Dr. Ben Shadler, in the recent work of you and others, is that increasing or decreasing the certainty that the planet is warming?
Well, the certainty that the planet is warming is increasing. I mean, it's as strong as it can be. I mean, we know that carbon dioxide is a heat-trapping gas, and we know that we're producing more and more of it. So the physics is really very simple, back-of-the-envelope complex. That conclusion is as strong as any scientific conclusion I can imagine right now. What we are working on very hard in the polar regions and the ice sheets in particular is understanding the processes so we can get good actionable numbers on sea level change. That is our primary issue in this whole complex climate system. And in that regard, I need to say that if you asked me 10 years ago, I think we would have given quite a different answer about how the ice sheets respond to climate. We have been absolutely astonished and amazed over the last few years how rapidly the ice sheets are reacting. And so that actually increases our uncertainty initially, but certainly pushes it to far larger values of sea level increase on much shorter timescales. And that's sort of where we are right now, fairly large uncertainty, but all the numbers are positive. None of the numbers are negative. And so as studies, as my colleague here, Andreas, has described on Peterman, unfold, we're learning more and more about the processes so that we can shrink these uncertainties over time. But the sign of sea level change is clear and I think unequivocal, as is the sign of global warming.
Do you agree with that, Dr. Min Chow?
Absolutely, I heard that, and I don't see, where I'm knocking you down. So, I think that's an unfair statement, because what I'm doing is I was talking about Peterman's.
So are you,
Peterman's
can I ask a question? Do you limit your expertise just to the Peterman glacier? You don't speak, you don't feel qualified to speak outside of that, is that correct?
I cannot speak as an expert
okay.
On the Greenland Ice Sheet itself.
Okay,
I can speak as an expert on Narrow Strait. I can speak.
No, I appreciate that.
I've been in the Arctic.
No, that,
the last couple of years, I'm looking at a lot of data, and I'm guided with my interpretation and with my statement, both in public and in my peer-reviewed record. I stick to data.
Okay,
and I think there's a danger. There actually is a danger to put a label on every event that this is global warming.
Again,
because that discredits the very data that's dear to our heart.
Again, as I said, again, Dr. Min Chow, I said that up front. We're trying to create something that looks at the total picture of what is going on. Dr. Ben Shadler said that each and every event now is creating the totality of a picture that points in positive, not negative. That is, that there is a problem. And he's looking at the totality of it. You are saying that you're not in a position, as a witness to be able to look at the totality because you're focused on Peterman exclusively. Is that correct?
I'm speaking
That's
exclusively.
okay. That's right. Just and again, it's very helpful that you stipulate,
and I made that clear in my statement as well.
Yes.
That's
again,
what I was talking about.
And I appreciate that. Okay. So let me go to you, Dr. Alley. How do you look at it in the totality of these events in terms of what is occurring? Dr. Alley?
Yes. So looking at the totality, and you're very, very spot on. And as you know, the Congress has created mechanisms to provide guidance for you that gives you the totality. And one of those mechanisms happens to be the U.S. National Academy of Sciences, which was founded in 1863 to provide advice during a very trying time in the government, and has been reaffirmed by statements by the first President Bush, by President Eisenhower. It was strengthened greatly by President Wilson as a provider of the totality view. And they have released quite a number of reports recently which have been very clear. We are changing the composition of the atmosphere. That is causing warming. That is changing a bunch of things that will impact us. Your government, in addition, through the administration, the previous administration, asked us to do these CCSP reports, and the one that I worked on was very clear. When it gets warm, the ice melts. The IPCC then does for the world what these bodies that you have created have done for the U.S. And all of the main assessment mechanisms, when they have looked at the totality of the evidence, have been very clear. We are changing the composition of the atmosphere. That is causing warming. That is impacting us with high scientific confidence.
Okay, thank you. So what amount of sea level rise should we expect by the end of the century? And is that more or less than the latest estimates of the Intergovernmental Panel on Climate Change? Dr. Ben Shadler.
Well, I showed the one slide that I hope answered that as best I can answer it, and it's pulling from the published literature. Every expert I know of in the field of ice sheet dynamics feels that the numbers that you'll see in the IPCC Fourth Assessment Report are underestimates. And in fact, the text of that report says that says that they cannot be sure, that they cannot provide either a best estimate or an upper bound to sea level rise, which was a very strong statement in that report. And so the slide that's being shown now includes 3 published estimates that came out after that Fourth Assessment Report. And 1 meter rise in sea level by the end of this century fits comfortably within those estimates. So if somebody would hold a gun to my head or shake me by the collar and say, give me one number, your best number, I would say 1 meter. If you're going to have to plan for something, I would say 1 meter. It has large uncertainty. We're working very hard to reduce that uncertainty, but that's the best number I think we have right now.
Dr. Alley.
Yes, I would agree with Dr. Ben Shadler. I have done the same thing that he's done. I served the IPCC, so I helped write that statement that we don't know what's going on because we were surprised. The ice sheet started changing much sooner and much more than we expected. We did not have good projections of this. And so because we were surprised, the terminology in a football game is we punted. We didn't quite know what to do, so we said it will be a small number plus whatever the ice sheets choose to do. Since then, there have been 2 big things done. One is that the modeling community, and Dr. Ben Shadler is organizing a lot of the modeling community, are trying very hard to catch up. They are trying to get to the point of giving you pound on the table, believe this, useful numbers. But it's going to take a while because we started so far behind. The other thing that's been done is many people have tried to make estimates from the back of the envelope. And Dr. Ben Shadler showed 3 of those estimates for you there. I have a collection of others. And a meter by the end of the century falls very comfortably within that collection. So none of us can give you the sort of pound on the table, trust us, we know what we're talking about answer that we'd like to. We just are not that far along scientifically. But a number that is notably higher than what was in the IPCC reports, and somewhere about a meter by the end of this century. And certainly that's a time, my daughters are likely to live to see that. So this is not that far away, but something like a meter by the end of the century seems to fit within our current understanding.
Right. And when you say 1 meter,
1 meter.
We're in the United States. So what would that translate to for people in the United States?
Yes. Clearly, if you live in Denver, it's not going to flood anything. But
No, I'm sorry, Dr. Alley. Dr. Alley, I just wanted you to say 3 feet. That's all.
Yes.
Because
you put I believe Dr. Ben Shadler had a map of sort of how much value and how many people are involved in that, and it's. If you're living, if you're worried about a storm washing over you now in Miami, or if you're worried about a storm washing over the levees now in New Orleans, and you put 3 feet of extra water in, it's a hard task.
Okay, can I ask a question? Are we reaching, so a meter is 3 feet. So you see a 3 feet rise in sea level. We just haven't quite gotten into this metric system in the United States. So when we don't really talk about centigrade or meters in the United States, we talk Fahrenheit and feet, and then you're communicating. This is also an important part of talking to the United States of America. Talking 3 feet. 3 feet actually sounds worse than 1 meter. Okay, so to an American, 3 feet is something that they can keep in their mind. So I just say that to you whenever you're speaking to American audiences, that it's helpful to translate it into what it is that we use as our own measurement system here. Well, I know that you spend a lot of time in international fora. Are we approaching a tipping point for the Greenland ice sheet by continuing our releases of greenhouse gases? How far off is that point, Dr. Ben Shadler?
What troubles me is that we may well be already past that point, but we don't know, to be honest. The reason I think we may be past that is that the full amount of warming, even from the current composition of the atmosphere, has not been realized yet. Even if we did not produce another molecule of greenhouse gases, the best projections are that temperature would rise more than 1 degree Fahrenheit. And what's that going to do to the ice sheets? That's another part that we don't know. One of the processes that my own particular research is following up is the connection between an increase in atmospheric circulation as it affects the increase in ocean circulation, and that delivers more warm water to the undersides of the ice shelves, causing events probably like we see with Peter Melling Glacier. And that's already in the system, and that has not fully expressed and manifested itself. So what troubles me, what keeps me up at night and gets me into the office early in the morning, is the concern that we may well be already past that tipping point, and there is nothing we can do right now to avoid at least a 1 meter rise in sea level by the end of this century.
Yes, I think Dr. Ben Shadler has hit it pretty well. Certainly what our estimates from that government report were somewhere between 2 and 7 Celsius of warming would be sufficient to remove Greenland's ice sheet sometime in the future. And we may be pretty close to the lower end of that with a little more warming coming. So I said sometime within the next decades we may cross that tipping point that puts us warmer than the temperature at which Greenland can survive. Greenland by itself, if it melts, raises the global sea level on average about 23 feet. The deepest water in New Orleans after the hurricane was about 20 feet.
That you're saying if we lost the entire Greenland ice sheet, it would raise the sea level in New Orleans by how many feet?
It's about 23 feet averaged around the globe, 23 from the Greenland ice sheet.
So do you see the Greenland iceberg as the canary in the coal mine? In other words, does the Arctic give us an early warning sign about the planet as a whole?
I believe the Arctic does give us early warning signs of the planet as a whole, and I actually was sort of convinced before this iceberg that there were enough other changes that we had observed so clearly in Greenland that we were headed in a direction which is dangerous for future sea level rise.
So what do, Dr. Ben Shadler, what do the polar regions have to teach us about global warming that other regions don't?
I think the way I would answer that is that it gives everyone a view into changes that societies will need to adapt to. Residents in the polar regions, especially in the Arctic, are living through global warming right now on a daily basis with the thawing of permafrost and the changes in their culture. One of the most compelling aspects of that I came across is that they don't even have words in the Inuit language to explain the changes that are being experienced now on a daily basis. So even in all their traditional knowledge and history, they don't even have language to explain what's happening.
The polar regions, though, they warm faster than other parts of the world. Is that correct?
They do. So it's essentially the front line of climate change, if you will. That is, and so for the rest of the people on the planet, they should look to what their fellow human beings in the polar regions are experiencing right now as a way of looking into their own futures.
Okay. Dr. Min Chow, as you look at this, can you see any reason for concern by what happened up in Greenland last Thursday? Are you concerned at all? You know, there seemed to be, you said there was a great deal of excitement that went through all of the people who were working on this. So was there a level of concern that your colleagues evidenced as they were witnessing this historically large break-off of ice?
I do indeed have a concern. Actually, I have a number of concerns. And one concern that I have is that we're happy with the level of knowledge and understanding of the physical processes of a very complex climate system, that we're happy with the level of knowledge that we have. I'm not happy with the knowledge that we have because there are a large number of physical processes that we do not understand. As a physicist, I like to know, and I think all physicists and most scientists, all scientists want to understand why and how has it happened. What we all observe is happening.
So is it warming in the area of the Petermann Glacier?
Yes, it is warming, but I think that's not the story in Petermann Fjord. The story in Petermann Fjord is that the interactions of the ocean with the ice, that's the big story. And kind of if someone, and I'm dealing with students, I'm educating students all the time. If a student comes to me and I'm asking him, why is it doing what it is? And I'm expecting him to understand it, or I want to teach him to understand it. I'm asking questions. I sometimes ask challenging questions. I sometimes create counterpoints. If all he has to do in order to pass muster to say this is global warming,
no,
that's not good enough.
I'm not asking for you to say that, but I'm asking you. So it is warming, though, in the Petermann
Yes,
fjord.
but I believe the warming, the local warming in and by itself is not important. That's not causing concern to me. What is causing concern to me is that we stop striding to understand any system.
No,
any
and I appreciate that, and that's what I'm trying to do. But has there been a reduction net in the amount of ice in the Petermann Fjord?
To the best of the knowledge, with the data that we have in hand, which admittedly is very limited, the answer to that is no. Actually, what we don't know about Petermann Fjord is we don't have, together with these breakup, with these extreme events that occur every 25 or every 50 years, we don't have the ice thickness that goes with it. We don't have the ice velocity with which the glacier is changing, surging, not surging. Is this in a steady state? This is not in a steady state.
So the first 6 months of this year were the hottest on record. Is the break-off of this particular ice mass more related to ocean temperatures, to air temperatures, or to both air and water temperatures?
All those factors that you mentioned play a role. The dominant factor for Petermann Glacier is the interaction of the ocean water underneath.
So you're saying the fact that it's been the warmest 6 months on record is really not a factor here compared that is significant compared to the ocean.
That's correct. That's correct.
Has that heat warmed the ocean?
We do not have enough data. We have been there in 2000, and this is the entire data record that there is. In 2003, we have been there collecting for one-day data. In 2007, we did it again. In 2009, we did it again. That's 3 days in 7 years. We didn't see substantial change that would cause us alarm.
So
but I'm not saying.
Are you saying that there is not? You don't measure the temperature of the water on an ongoing basis?
That's correct. We're not measuring temperature on an ongoing basis in Petermann Fjord. That's correct.
Why is that? We know we're having like the warmest waters off of Massachusetts and Maine and in July, and we advertise that. Come and swim it. You can go out into the water in Maine right now in a way that we would just put our foot in when I was a little boy in Maine and just stand there while my father would just challenge us, his 3 sons, to come out and show that we could stay in that cold water. But now people are out in July in the water in Maine. It seems surprising to me that you're not measuring the temperature of the water.
If I could, I would, and perhaps that's what I would like to do, and that's what kind of in my testimony I was trying to emphasize, that we do need to measure ocean currents.
Well, let me ask you this. Are average water temperatures around the world going up?
I did a study in Baffin Bay, and at the surface
but around the world, is it on average going up, the average temperature of the ocean?
In some regions it does, but there's also regions.
But on average, what I'm asking is, on average, is the world's oceans, are they warming? Dr. Alley, could you answer that question? Are the world's oceans warming?
Yes, they are. Heat averaged over a few years. Heat is going into the oceans. The oceans are warming. The database is good on this. There are important places that we worry about that are not yet monitored well. So the temperature under Petermann Glacier for a long time, the temperature around Antarctica close to the ice sheets is not monitored. The world ocean as a whole, the data show warming. And a fair amount of heat going into the ocean. And as Dr. Ben Shadler said, this in turn means that we are committed to more warming of the air, because as the ocean catches up, the air will warm a little more. There are places that we worry about a lot. The question of what will Greenland and Antarctica do in the next decades is linked in part to the heat in the ocean. And right now, the places really close to the ice and under the ice are not monitored well.
Can I ask you this? Okay, thank you.
If you were to ask us, in fact, Dr. Ben Shadler and I were at a meeting recently that was trying to provide some advice to the National Science Foundation on things that one might wish to measure, and both of us mentioned that knowing more about the ocean temperatures close to the ice sheets is very important.
Can I ask you this, Dr. Min Chow? You said earlier that when you talk to your students that you focus more upon the water than on the air as a factor, and that you feel that you have an obligation to your students to focus upon the water to explain the phenomenon that are occurring. Do you think that it would be wise to actually measure the temperature of the water so that your students knew whether or not the temperature of the water was changing in order to determine whether or not the general warming trend in the ocean was playing a role around the Peterman.
I teach my students how to measure temperatures, how to measure salinity.
Excuse me?
I teach my students how to measure temperatures,
but you
salinity,
do not
ocean
measure,
currents.
you're saying this, your study itself does not, in fact, measure the temperature of the water. Is that correct?
Mr. Chairman, none of us has been funded.
No, I am not criticizing you.
The reason
I'm just trying to stipulate the limitations of your study. On the one hand, you're saying you believe it's more water than air, but at the same time, you're saying that because of a lack of funding, that you do not have a capacity to measure any increases in the temperature of the water, even though we see a clear international trend towards the warming. And I think what we should try to do, perhaps, is to help you so that your study can reflect that, because right now it seems to be limited by an inability to be able to precisely measure the water temperature. We can measure the air temperature, of course, and that seems to be increasing. The polar region does warm more greatly, and if we could actually help you with your funding. Who is your funder, by the way?
That's the National Science Foundation,
the National
which has
Science
been
Foundation.
funding.
So this is a limitation, without question.
Yes.
That seems to me, at least as an amateur, I am a congressional expert as a oxymoron. You know, we're not really experts compared to scientists. I mean, it's like jumbo shrimp or Salt Lake City nightlife. I mean, there are no actual congressional experts, so we rely upon you. But there seems to be a pretty big gap here in terms of your ability to be able to speak, since Dr. Alley has made it quite clear that the ocean is warming. Okay, and we know that. Okay, that if that warming, Dr. Alley, do you believe that warming is related to global warming? Dr. Alley?
I'm sorry, sir. I lost the very last of your question. If you could repeat it, my apologies.
Is the warming of the ocean related to global warming?
Yes, sir, it is.
Yes, there is. So that if the ocean is warming around the Peterman Fjord, it hasn't been measured, of course.
We don't know that yet.
I just said if. I just said if. Dr. Min Chow has not measured it. He does not have the funding to measure it. And so he doesn't know. He has to stipulate he does not know whether or not the water around the fjord is warmer than it was 10 years ago. He just doesn't know. Okay? But yet he's saying he believes it's mostly related to ocean as opposed to air. He's confident of that, even though he hasn't measured the ocean in terms of a warming temperature at this point, as an additional factor that would actually enhance the ocean as a factor. He can't quite build that into the equation. Is that correct, Dr. Min Chow?
I lost what the question was.
The point of the question is that you say you believe that the change in the stability of the Peterman Fjord is more related to ocean than to air, but that you have not actually measured the temperature of the water around the fjord because of a lack of funding. Is that correct?
That is correct. I've been funded, and I have 7 years of time series data that is every 50 minutes.
I'm just trying to understand the limitations of your funding.
Okay. The limitation of my funding, I mean, this is a very sore point. Limitation of some of my funding is to the point that for the last 3 years, I've been basically paying airfare for myself and my students to participate in Canadian icebreaker cruises that collect data there, that I collaborate with, that depend on, to some extent, on my expertise. This is joint work. I basically pay that out of my own pocket.
Again, Doctor, I'm not, again, I am in no way criticizing you. What I'm saying is we want to help you to get the funding so that we measure the temperature of the water so that we can see if there's a correlation between the warming of the ocean. We know the air is warming in the polar region because it warms faster than other parts of the world. And if the waters are warming as well, then you have a pincer movement on the Petermann Fjord that may be intensifying. That while you said earlier, this one huge ice block that has now collapsed only leads to an average over the last 30 years or so that's consistent with historical averages, that if we could see it in the context of temperature and water temperatures rising, perhaps we might want to discard the historical average and start to look at this in terms of phenomenon that it might be more equivalent to in other parts of the world, and to do it in that context. And that's the only point I'm making here. I just think that there are limitations because of funding questions from the NSA in its relationship with you that make it more difficult for you to speak to the totality of what is happening up there, which is unfortunate, although we stipulate that your work is needed in order to understand what is going on. Professor Jason Box of Ohio State's Bird Polar Research Center reports that last year he emplaced cameras upon the Petermann Glacier that have been shooting time-lapse photos of the glacier for the last year. He lacks sufficient funding, however, to go back up there and retrieve those cameras and the data inside of them. Would it be helpful to our understanding of what's going on up there to get those photos, Dr. Min Chow?
Absolutely. I mean, this is absolutely imperative because these type of remote regions where it's very difficult to get to, where it's very expensive to get to, we actually are in exactly our group, and this includes my Canadian collaborators as well as collaborators at Oregon State. We are in exactly the same boat. We have instrumentation in the water right now that is not just measuring ocean currents throughout the water column at 4 different locations near Petermann Glacier. It's admittedly narrow strait where this iceberg will go into kind of within the next 2 weeks probably, but also on ocean currents and ice thickness. So we would like to see, we have instruments in the water right now. This is, again, bootleg. This is not funded. This is something that kind of, I mean, I'm actually going, or we as a group go out on a limb. If we tell this officially, we're not supposed to do that.
Well, can I say this honestly, and I appreciate the limitations on your research. One of the things that people don't understand about the measurement of temperatures in the United States is that we actually use thermometers. It's a modern technology, not related to paleoclimatology, but just thermometers that measure how warm our country has become over the last century. And so that's a pretty simple, prosaic technology that it seems to me we should be able to apply to the oceans surrounding Greenland. And it seems to me that that's something that we should be able to find a way of factoring into any study which is taking place. Dr. Ben Shadler.
Yeah, if I might add just a few comments there. Measuring the ocean temperature in the polar regions is hard. It's really hard. My own proposal 4 years ago was finally approved to measure temperatures beneath another ice shelf, an Antarctic ice shelf. We won't have the first opportunity to do that until 2011, 2012. So we can go into a long discussion about why that's difficult to do. But I do want to emphasize also that the scientific community well recognizes that ocean-ice interaction is the highest priority in addressing quantification of land ice loss and its contribution to sea level. And that harkens back to the meeting that Richard Alley referred to, that we had 8 basic research questions. The ocean-ice interaction and understanding that turned out to be the highest priority. So there is a definite research need. But and polar research needs to be understood that it advances actually more slowly because of the extended polar night, not just the harsh conditions, but the fact that the opportunities for field work are limited throughout any given year. But certainly funding will help. We're looking to help from the U.S. Navy to actually help us with some of their observational capabilities. So they're on board and quite interested in helping us collect the kind of data that Dr. Min Chow says is so critical, and I certainly agree with it. So,
May I add to that?
Let me just make this point. There is a crime against nature which is being committed as the oceans and the air warm in the Arctic and around the planet, in the same way that a crime against nature was committed in the Gulf of Mexico by a lack of attention paid to the technology which should have been in place in order to deal with what turned out to be the worst environmental disaster in our country's history. The assurances that were given that an accident like that could not occur and that a response was possible, in fact, turned out to be completely inaccurate. And it was a combined failure of the private sector and the public sector that led to that catastrophe. And you're sitting at the table where the hearings were held with the CEO of BP and other experts over the last 100 days. We, it seems to me, have an obligation to ensure that there is proper funding for these kinds of scientific experiments that can ensure that we understand what is taking place. We right now have really no idea what the impact is of shooting a couple of million gallons of chemicals into the ocean following a couple of 100 million gallons of oil. We know next to nothing, especially at 5,000 feet in the ocean. So I think we have an obligation here. Something significant has occurred. It obviously still, even with all the best experts that we have, lacks the full understanding of what is occurring, notwithstanding the best experts of the best scientists. So I think there's enough reason here, though, to believe that a crime against nature is being committed in Greenland and in the Antarctic, and that all of humanity will suffer unless we get the conclusive evidence that then leads to action being taken by not only this Congress but by the legislative bodies of the world to prevent it accelerating into something that's much worse than 3 feet of sea level rise, if we have already passed that one tipping point. There are others in the future. So here's what I would like to happen. I would like to give each one of you a 1 minute, 1.5 minute summation to the committee that we can rely upon. We'll go in reverse order of the opening statements, and we'll give you, Dr. Min Chow, the final concluding statement.
Thank you so much, Mr. Chairman.
If you could turn on your microphone, please.
Thank you so much, Mr. Chairman. The polar research in the field is indeed, as my colleague Dr. Ben Shadler said, is indeed very hard and challenging because it pushes the envelope. The hard part, it's easy to put instruments in the water, and be it as something as simple as a thermometer. The hard part is to get it back. And then the harder part yet is to properly interpret it and kind of derive knowledge from that original knowledge that improves models and physical understanding of the climate system. The instrumentation that goes into polar research is also a challenge for American business and technology. And as an example, I like to point out that in order to have measurements programs at these high Arctic regions near Petermann Fjord in Narrow Strait, where our group has been successful to recover instruments since 2003, is that it's not, at the time, no company could ensure that instruments could stay in the water for 3 years. We worked with manufacturers, American manufacturers, so that they would re-engineer, according to our specification, some of the instrumentation to make them work for 3 years. That company now has a competitive edge to market their instrumentation that could function unattended for 2 or 3 years because we did it working with private companies in order to tackle challenging problems. So I think there are benefits from doing climate research. There's benefits that to keep researchers kind of funded so that they can do the basic measurements, and temperature is a very, very basic measurement of the ocean. But there's more, and we can do more, and we do more. Yeah, but we cannot do it. I mean, on our own private funds that we then write off the taxes. That does not work, or that would result in extremely spotty or no data at all.
Okay, thank you, Dr. Min Chow. Dr. Alley.
Yes, thank you so much for the opportunity to address you. CO2 is a greenhouse gas. The scientific confidence is remarkably high that we are raising CO2 rapidly and that that's affecting the climate and that's affecting us. When you make it warmer, ice tends to melt, and a lot of that ice is on land, and that raises sea level. The big picture is very clear. The more detailed regional, local questions that people often really care about: was this event caused by global warming? What exactly will happen to sea level where I live? We can't give you the strong answers yet, and with more support, I'm sorry, I hate to beg, but with more support, we can have more fun doing science and we can give you better answers. They will not change the big picture, which is that we're changing the atmosphere, that is affecting the climate, and then that is affecting us. Thank you.
Thank you, Dr. Alley. Dr. Ben Shadler.
Much along the lines of Dr. Alley, I would say that the Peterman event that brought us here to you today is probably a note in a much larger chorus. And it's that chorus that I want to address. As Dr. Alley said, we know that the world will continue to warm, and we know that that is going to lead to less ice and higher sea level. And that is job one for my colleagues in the community that I share, trying to understand how the ice sheets are going to respond to climate in detail, because we understand that those details are terribly, terribly important, and the ocean-ice interaction is perhaps the most critical piece of that. And so measurements are being planned and are actually being executed to learn more about that, so we can come back with better information. Right now, the best information we have, you've seen it, the expectation that sea level will rise something like 1 meter by the end of this century is a number that keeps coming up in the various analyses that we conduct. But we know that's not good enough, and we have to improve the details of our projections so that we can give decadal scale projections for policymakers and planners. We're hard at work on that, and I certainly want to harken back to what Congressman Inslee said, that many, many, many of people in my community are eager to do all that we can to communicate this more effectively to more people. We are deeply disturbed by what we see.
Thank you, Dr. Ben Shadler, very much. And again, let me just conclude by saying that we do stipulate that no one event, including what has happened at the Peterman, is conclusive proof of global warming, but looked at in the totality of all of the evidence that exists from around the planet. It is part of a pattern which does, in fact, exist. One of those indications is that for centuries, explorers searched the world for the ultimate commercial superhighway. And we are now dealing with that reality thanks to the impacts of global warming, as the Arctic ice has receded, so that whether it be Russia, the United States, Canada, Norway, there are now intensifying efforts to move to the Arctic in order to capture international rights, where once there had been ice, there are now ice-free pathways that can be used for commercial purposes and ice-free areas that might be exploited for natural gas and oil exploration. It's just another piece of this story. But the Arctic, it seems, is the canary in the mine shaft. It is the scene of the crime where the evidence is mounting most rapidly that something very, very significant is occurring. And while no temperatures of water may be measured around the Peterman Fjord. You don't have to be Dick Tracy in order to see that the ice is receding, so that nations are now fighting over the passageways that have tremendous national security and economic potential for countries around the world. It is all part of a larger story, and the Peterman fits into that puzzle almost perfectly. Not conclusively, but another piece of evidence that something is happening, and that this Congress, this country, must be the leader in order to have the rest of the world follow in a way that will avoid the worst consequences of global warming. So we thank each and every one of you for your testimony today on very short notice. And with that, this briefing is concluded.